children. My name is Shushmita. In our previous session, we have already read all about the atomic models. Now, it is clear to us that there are three types of subatomic particles in an atom. They are called electron, proton, and neutron. If in all the atoms these three particles are present, how can we distinguish them? Due to that reason, we need to know how many protons are present in the atom of any element. This time, we will read atomic number and mass number. Let us start the session. Before starting the new session, let us revise the previous one. Neutron is an uncharged particle that is a part of the atomic nucleus. Credit for the discovery of neutron goes to J. Chadwick. Niels Bohr proposed that electrons are distributed in different shells with discrete energy around the nucleus. If the atomic shells are complete, then the atom will be stable and less reactive. Shells of an atom are designated with letters as K, L, M, N. Learning outcomes. At the end of this session, you will be able to understand about atomic number, electronic configuration of atom, mass number, isotopes, isobar, isotone. Keywords: atomic number, proton, nucleus, orbit, energy level, electron, neutron, mass number, isotope, isobar, isotone. Let us look at the concept map of this lesson. Our first topic of today is atomic number. Do you know that hydrogen atoms have just one proton in their nuclei? Only helium atoms have just two protons in their nuclei. Indeed, only gold atoms have 79 protons in their nuclei. This shows that the number of protons in the nucleus of an atom decide which element it is. This very important number is known as the atomic number of an atom. It is denoted by Z. One thing we need to always remember is that due to the electrical neutrality, number of proton is always similar with the number of electrons. Protons alone are not responsible for making up all of the mass of an atom. The neutrons in the nucleus also contribute to the total mass. The mass of the electron can be regarded as so small that it can be ignored. Number of protons and number of neutrons present in the nucleus of an atom is known as the mass number of an atom. It is denoted by A. For any element, the atomic numbers are shown as subscripts and mass number are shown as superscripts. For example, the atomic number of nitrogen is written like this. Here, 7 is its atomic number and 14 is its mass number. You already know that electrons occupy different energy levels called orbit or shells. The distribution of electrons in different shells is called electronic configuration. This distribution of electrons is governed by certain rules or conditions. Rule 1 is the maximum number of electrons that can be accommodated in a shell is equal to 2n square, where n is the serial number of the shell from the nucleus. Rule 2. Shells are filled in a stepwise manner in the increasing order of energy. Rule 3. The outermost shell of an atom cannot have more than 8 electrons, even if it has capacity to accommodate more electrons. For example, electronic arrangement in calcium having 20 electrons is 2 electrons in K shell, 8 in L, 8 in M, and last 2 electron is in N. What is the electronic configuration of aluminium? In aluminium atom, atomic number is 13. So, the K shell contains 2 electrons. L shell has 8 and M shell has 3 electrons. So, its electronic configuration is 2, 8, 3. This is the chart of electronic configuration of the first 20 elements. In nature, a number of atoms of elements have been identified which have the same atomic number but different mass numbers. They are called isotopes of that element. For example, take the case of hydrogen atom. It has 3 atomic species as shown on screen: protium, deuterium, and tritium are the isotopes of hydrogen. Let us consider 2 elements: calcium with atomic number 20 and argon with atomic number 18. They have different numbers of protons and electrons. But the mass number of both these elements is 40. It follows that the total number of nucleons in both the atoms are the same. They are called isobars. On the screen, you can see the pair of elements boron and carbon which have the same number of neutrons but different number of protons and hence different atomic numbers. Atoms of different elements with different atomic numbers and different mass numbers but with same number of neutrons are called isotons. What you have learned today? The atomic number of an element is the same as the number of protons in the nucleus of its atom. The mass number of an atom is equal to the number of nucleons in its nucleus. An atom with 8 electrons or an octet in their outermost shell is chemically stable or does not combine with other atoms. Isotopes are atoms which have the same number of protons but a different number of neutrons. Thanks for watching this video.